All right, welcome. We're going to do a quick video to hit one of our first topics for this unit, which is understanding the difference between distance and displacement. These are pretty simple things, but they can be a little bit confusing, largely because we have some vocabulary that goes through each of these. And so what we're doing really is describing motion. We're describing how an object moves from point A to point B, or in some cases, point A to point B to point C. And looking at whether we're kind of taking into account everywhere that it's going, or we're only going to look at from where it started to where it ended. So if you can hopefully follow along with the notes that you've been provided. And we're going to start with this, just kind of look at the difference between distance and displacement, and then get into some examples of being able to answer some questions regarding something's motion and answering its distance and displacement. So we'll start with distance. Most of us probably have a pretty good idea of what distance is. It's simply the total length an object travels. All right, so you can think of as how far did something go? For those of y'all that are driving, this is kind of what the odometer does in the car. That's the little thingy where the miles add up. If you've got a digital display, or it actually still an older car where it turns. You know, it doesn't matter which way the car is going, as long as it's moving forward, that distance is going to be adding up. Okay, so in other words, the distance depends on the path we take. You know, if we go straight, it adds up. If we have curves, it adds up. If I drive to work and then drive back home, all of that adds up. So it's totally dependent on the path. And if I go out of my way, then my distance is going to be a bigger number than it would if I just took a straighter path. All right, another vocabulary word that comes in with this is scalar, and we'll see this throughout the semester. Scalar looks like, you know, there's the word scale in there, like some kind of a measuring tool. But distance is a scalar measurement, and what scalar means is that there's simply all that we're looking at is the magnitude of a measurement, or the magnitude of the motion. And I use this word purposely because we see magnitude throughout the semester as well. And all that magnitude really means is the amount. Okay, so scalar just tells us how much, and that's it. It's pretty simple. So when we're measuring the distance of something and we have a scalar measurement, it's just simply going to be something along the lines of 3 meters. So usually we're going to have a number, and usually we're going to have some kind of a unit. Again, one of the things we want to get used to in physics is using our units, because our units can tell us what that number is. So when we say meter after a number, we know that that's a distance, because meter is a unit of distance. So that's one of the things we'll do throughout the semester, is hopefully focus on these units as well, so we can remember what the number is telling us about. All right. I'm going to contrast this a little bit with displacement. Displacement is similar to distance, but there's a little bit of a change in it. So what it does is it tells us the change in position. And if you look on the slide right here, it's got this triangle P. Well, what the triangle is, and I'm going ahead and telling you this because it shows up throughout the semester. You may have seen it in chemistry as well. That triangle is actually the Greek letter delta. The Greek alphabet has all kinds of interesting characters in it, and sometimes we use them in science because we run out of English letters. And so delta always is telling us that it's a change in something. So displacement is a change in position. All right. So if you want to make this a little bit simple, it's how far you are from where you started. And then the second part of it is what direction did you end up going, if you want to compare your end point to your beginning point. All right. So distance, the path mattered. And when displacement, the path doesn't really matter. And unlike distance, which was a scalar measurement, displacement is a vector measurement. And a vector is a scalar, but it includes direction. All right, so again, it's similar. Vector and scalar are two words that go together. Scalar, as we saw a minute ago, would just be like 3 meters, whereas if we have a vector, it's going to be not just 3 meters or 5 meters. We need a specific direction, like east or west or north or south or up or down, left or right. So we need to know where did it move and in what direction. We'll do a lot of measurements this year that involve vectors, because as we'll see for the rest of this unit, we'll start doing some other calculations that involve displacement. And if it involves displacement, it's a direction and it's a vector, and that influences all kinds of things. So 4 vocabulary words: distance, displacement, scalar, vector. Again, not too complicated, but we're going to try to practice with them until we get used to them. All right. So again, displacement is not dependent on the path. It's kind of independent of the path. All that we're looking at is the starting and ending points. All right, so we're going to look at some examples of things that you might be able to see. These are on your sheet as well. So the first one says determine the distance traveled and the displacement of the skater that moves from point A to point B to point C. So if you look at your graphic, we got the skater that's on here, and this is on a number line. And you can see that we've started at point A, which is at -20. B is over at, it's beyond 10, but you'll hopefully infer that each of the dots represents at 5. So A is at -20. B is at 15, and C is at -5. Okay, so if we wanted to do the distance, we need to just add up everything. So how far is it from A to B? So on the number line from A to B, if we go from -20 all the way to 15, that's going to be a change of 35 meters, right? So again, -20 all the way to +15, that's going to be 35 meters total. Again, these are always going to be positive numbers because we're always just saying how far is it? Doesn't matter if we're moving left or right, we're always going to get a positive number. And then from B to C, again, we're going from 15 meters back to -5. That's a change of 20 on and if you need to use the number line, you can do that. So for distance, we just added those up. 35 and 20 is 55 meters. How far did you skate? Skated 55 meters. That's the distance. Slightly different again, displacement, if we're using the same image and we want to say, what's the displacement of this situation, then we don't really care anything about B because all that we care about is the beginning and the end. So what is the change from the beginning to the end? What's the change from A to C? Again, we can kind of skip out the whole B part. So how far is it from C to A? It's 15 meters. All right, and then the second part though is again, what direction is it? In this case, we don't really think of north, south, east, west, but we can say that it's to the right because if we move from A to move to C, we are moving in the right direction. So put both of those together, the displacement ends up being 15 meters to the right. Again, and that's a vector, whereas for the distance, it was just a scalar measurement. Okay. Some more examples. If Robbie leaves the cafeteria, so if he goes 25 meters straight down the hallway from the cafeteria south to his physics class, all right, what's the distance and displacement? Well, because the beginning point and the end point are basically in a straight line and he didn't change direction, then the distance and the displacement are going to be the same amount. So he walked 25 meters straight, the distance is 25 meters. The displacement is also going to be 25 meters, but we want to add a direction to it. And in this case, the direction was given to us as south. So in this case, the displacement is almost the same as the distance, but we include the direction to make it a vector. And then it's going to be 25 meters south. All right. Third one. It says to get your cell phone back, you've got to chase your brother around the dining room table. What's your distance and what is your displacement? So sometimes with these, it's a little bit helpful to make an image so that you can draw it out. In this case, we would kind of have to have an image because it didn't give us the numbers. But if the question gave you numbers about which way that you were moving, sometimes it's really helpful to draw it out so that you can see it. So again, what is our distance? What's our displacement? Distance is the total amount that we went through with the path. So we're running all the way around the dining room table. So we go up 2, to the left 3, down 2, back over to the right 3. Just add all those numbers up and the distance is 10. So we move 10 meters. The displacement, again, what are we doing? We're comparing where did we start with where we ended. Well, in this case, we ran all the way around the dining room table and came back to where we started from. So our displacement is 0 because we're back where we started from. So a little bit of a tricky thing. Oftentimes, we may feel like we're going great distances, but if we end up back where we started from, our displacement is 0. When I go to work and come back home, at the end of the day, my displacement is 0 because I'm back where I started from. All right, so this is not on your sheet, but if you just look at this graphic, the starting point to the end point, all right? So the pathway that's curved, if we were measuring that, that would be our distance. So if we were kind of filling in these green boxes, the top box should be distance. Whereas if we were just comparing the beginning and the end and we didn't really care about the path, that would end up being our displacement. right. We had this last image again. This one's also not on your sheet, but again, this kind of like the one going around the table, distance to displacement. If we did all 4 of these arrows, and we would just add them up for distance. So 3 plus 3 plus 3 plus 3. So our distance would be 12 meters. And our displacement, since we end up back at our starting point, is going to end up being 0 one more time. So displacement would be 0 meters. You don't really have to have a direction for 0 meters because you didn't move a direction. So our distance, again, distance would be 12 meters. Displacement would be 0 meters. Hopefully that's enough to get you going and be able to get help with things if you need to. So there's some there's some additional problems that you can work out and try on your own. If you need help, maybe work with people at your table or come ask me for help if you need it.